Let's now learn how to integrate powers of tangent. These integrals look like this, where m is the power of tangent, and m can be either even or it can be odd. The first case that we're going to look at is when we're integrating a power of tangent and the power is even. In our first example, we are going to integrate tangent squared x dx. To integrate tangent squared x, we are going to need to use the trigonometric identity that I wrote over here on the right. Tangent squared is equal to secant squared minus 1. The reason that we have to use this identity is we know the integral of secant squared, but we don't know the integral of tangent squared. Let's go ahead and let's make this substitution. We have the integral of tangent squared is now the integral of secant squared x minus 1 dx. We can just go ahead and integrate that. Integral of secant squared is tangent x. And then we subtract off the integral of 1, which is x, and then we add on our arbitrary constant. And there's our answer. For our second example, we are going to integrate tangent to the fourth x dx. This one's a bit complicated, so I wrote down 3 steps that we can follow, and I'll walk through these steps one by one as we work through our example. Let's go ahead and let's write down the problem. We're integrating tangent to the fourth x dx. Step 1 tells us to pull off tangent squared x. Let's go ahead and let's do that. I'll label this step 1. So we have the integral. If we pull off 1 tangent squared x, we have a tangent squared x left. Now let's talk about why we're doing this. The reason that we're doing this is that we can take this tangent squared x that we just pulled off and rewrite it in terms of secant squared, and the derivative of tangent is secant squared. That's explained up here in step 2. We're going to use tangent squared is equal to secant squared x minus 1 to rewrite our tangent squared that's highlighted down here in pink. Let's go ahead and let's do that. We have the integral tangent squared x, and then now the tangent squared that we pulled off can be written as secant squared x minus 1 times dx. We really have 2 integrals here, so let's go ahead and multiply this out. We have tangent squared x, secant squared x dx, minus the integral tangent squared x dx. Let's go ahead and let's work on the integral on the right first, because this integral on the right is also an even power of tangent, and we're going to do the same thing. We are going to take this tangent squared right here, and we are going to rewrite it as secant squared x minus 1 dx. And then let's go ahead and let's just integrate this. This is minus the integral of secant squared is tangent x, and then the integral of 1 or minus 1 is minus x. So let's go ahead and let's multiply this negative through. So this is minus tangent x plus x. I'm going to highlight this, and we are going to put that in our pocket and hold on to that until we finish the first integral. Let's now go back up to the top and let's look at step 3. We are going to let u be equal to tangent x, and then we'll integrate using u-substitution. We'll put a 3 down here. So we're going to let u be equal to tangent x. We are referring to this integral right there. And then du is equal to secant squared x dx. We'll draw an arrow here so you can see where we are. We have now the integral tangent squared, so that's u squared, and then secant squared x dx is du. So this becomes u cubed over 3, and then u is tangent, so we have 1/3 tangent cubed x. And that's our first piece. Now all we have to do is combine these two answers. So we have the integral tangent to the fourth x dx is equal to 1/3 tangent cubed x minus tangent x plus x, and then we add on our arbitrary constant c. And there's our answer. The second case that we're going to look at is when we're integrating an odd power of tangent. The example that we'll walk through is tangent cubed x, and notice that 3 is odd. I've written down steps that we can follow, and we'll walk through these one by one as we work through our example. Our first step is to pull off tangent x, just one of them. Let's go ahead and let's do that. We have the integral tangent cubed x dx. So our first step is to rewrite this, pull off one tangent x, so that leaves us with tangent squared x times tangent x dx. The reason that we're doing this is this leaves an even power of tangent, and we can rewrite that in terms of secant squared, and the derivative of tangent is secant squared. I wrote that up here in step 2, and that's what we're going to do now. We are going to take the tangent squared that I have highlighted in blue and rewrite it as secant squared x minus 1 times tangent x dx. Now let's go ahead and let's make this two integrals. Our first integral, we have secant squared x times tangent x dx, and then we have minus the integral tangent x dx. For this second integral, we can just use the formula. The integral of tangent x is the natural log of absolute value secant x. You just get that by rewriting tangent as sine over cosine and then use u-substitution. Now we have to evaluate our first integral. Let's look up here to step 3. Step 3 says that we are going to let u equal tangent x and integrate using u-substitution. Our u is tangent x, and then our du is secant squared x dx. So this gives us the integral of u du, and this is just u squared over 2. We'll bring the 1/2 out in front, and then we just plug back in that u is tangent x, so this is 1/2 tangent squared x. Now we have two pieces, our second integral and our first integral. And then let me highlight this negative because that has to carry through to the second integral. And we can go ahead and write down our answer. The integral of tangent cubed x dx is just 1/2 tangent squared x minus natural log absolute value secant x plus our arbitrary constant c. And there's our answer. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.